Welcome to everybody to our first GNOSIS Connect of 2025. I hope that everyone had good holidays, and thank you for making this time to be with us for one of your early priorities for this year. I'm pleased to be able to welcome Martin Coleman, who's agreed to do our first talk of the year. Martin has decades of experience in the satellite industry, and he is non-exec on the board of the Satellite Satcoms Innovation Group. That group was established in the late 1990s to tackle radio frequency spectrum interference issues. So he's been examining these issues of RF fragmentation and interference for years. This is a subject matter expert on that topic, and I'm really looking forward to hearing about his current thinking and the sort of latest state of play. Without any further ado, I will hand the floor to Martin, but I do want to just invite people to please introduce yourselves, put comments in the chat, put questions in the chat. We'll be monitoring that, and there will absolutely be hopefully time for Q&A at the end. So, Martin, over to you.
Thank you, Catherine. It's a pleasure. Welcome to everyone. Happy New Year as well. Well, let's dig straight in. Let's not go any further. We're into RFI, the great radio frequency interference bugbear. So let's get straight into that. So where are we? The state of it at the moment. This is a recent survey by SIG itself. We're still seeing RFI. It's like it's never talked about. It happens. It's happening all the time, and it's in greater than multiple times per week. You know, this is going on all the time for satellite operators around the world. Okay, my view is on commercial space, commercial satellite operations. But to be honest, you can move this into any part of space, and certainly even our dear military colleagues as well. It's the same problem. And of course, you know, guess what? It's us that cause most of the problems. So there we go. Probably no surprise. I'm not telling you anything new yet. And the solutions, they're all there. The classics, geolocation, of course, is always at the top. But things are changing. Ignoring what I've written there, things are changing because space is changing. In fact, it's not changing, it's changed. The change has happened. And what am I thinking? Leo. So let's keep going. So the downsides of what we do, we're very reactive. We're not proactive. We'll come to that in a minute. Alternative, excess capacity. It's a whole problem of coordination and cooperation. It is hard, very hard work. It's the same as situational awareness. It's hard work and it's hard to get. The thing is that, it's under the quality part is often cut in favor of commercial pressure in our side of the fence. That's not so in other people's cases. And I think it's time the commercial side had to balance that book a little better. However, going back to what it all means, we have no data. Now, we do have data for situational awareness of the physical side of space. But that might be priority one, but I'm going to put priority 1A is certainly spectrum. And Catherine mentioned earlier that, she thinks space weather perhaps ought to be 1A and spectrum might be 1B. But whichever way round we put it, spectrum in any of its forms is just, imagine not being able to even control your satellite constellation. Imagine that if you couldn't. Interesting thought. So, deliberate interference, I'll just skip this. It's sporadic, it's harmful, we know it, but it is a special case. Unfortunately, it's still going on, and of course, good old Ukraine has been a classic cause of the recent spate of deliberate interference. But it's a hard one there, and it's probably outside of what we're looking at today. But here we go. Software-defined satellites, they can be smarter now. We've even got colleagues that are working on satellites that can actually geolocate from space now using the actual technology they weren't even designed for, but because they're software defined, we can do things like that now. AI, machine learning, the data collection, but where is the data? There's an interesting one. AI would be incredibly useful in this, but if we don't have data, there's nothing to learn. Keep that thought. The failure of imagination and innovation. I like this one. I'll leave you to imagine what you think the failure of imagination and innovation. Perhaps we don't talk enough. It's not so much talking, perhaps we don't do enough. Regulation, yes. Oh boy, I'm not keen on regulation myself. It feels slow. And if we go on the ITU of managing spectrum in 4 years, as we put it, it's an 8 year cycle when you think about we try to manage our spectrum and then we agree what it is. And then 4 years later, we do that again when actually technology is probably changing every 8 minutes. I don't know about 8 years. It's a problem. So spectrum itself, well, we've said it already. Leo, 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 and MEO as well. But that is smaller, just because sheer numbers of satellites in that area it's small. Leo to GEO has always been the worry. Again, interesting thought. Spectrum's on the move. Spectrum is now a conjunction problem. It's not something fixed and easy. In fact, my whole commercial life has been sitting looking at geo. I know I always found astrophysics very complicated for me, but you know what? Geo is so simple. Now you move the world into the Leo constellation. That simplicity has just disappeared overnight. And it's now. Remember, there's close on 7,000 operational Starlink satellites. Nearly the complete fleet of OneWeb's up there now. And, we've got more to come. Kuiper's coming. It's large numbers. So for us, we don't have SA anymore in this group. In SIG, we talk about S3A. We added the third S. We put spectrum in there because spectrum is a situational awareness problem now. And the tools aren't there to deal with that. We don't know what we're doing. We're back to guess what? No data. This has been if I can't think how many years we've been saying it. But getting data from satellite operators, well, yes. Anyway, herding cats, I think, is a common phrase I hear often. It's not their fault. It's not an individual company's fault. It's just almost impossible because of the commercial pressures between operators. The drive to automate, well, I like the last bit I put on there. Algorithms don't close tickets at the moment. In other words, we've got no way of automating our way out of the human resource, yet we want to keep our operations costs down. Got to do something. And just as a reminder, it's supposed to be for all of us, not just commercial. It's the military, astronomy, it's everything, anything, exploration. Catherine can fill up any other thoughts. I'm sure she could add a whole list of things that spectrum is involved with. But it is limited. We have to abide by the rules, and there's only so much of it we can use. It's not that. I don't know why it's so difficult for people to manage this concept, but it isn't that difficult if you get it right. And the quality of the equipment you use has to be good too. That doesn't necessarily mean expensive. I'm talking about the quality of the design. If it's mass produced, it's probably cheap as chips. If the design's really good, you get really good quality, cheap as chips all the time. But we do need new tools. And I've always wanted, I'm being me now, I've always wanted to predict what's going to happen, not be chasing my tail every time and going backwards. We are always with RFI. It's a one step forward, it feels like, and two steps back. I'm sure my colleagues would say it's two steps forward and one step back. But, that's how it feels that what we do. So I'm not going to go commercial, but I'm going to introduce a thing called Thrymos. It's at the bottom of the slide. I shan't rabbit that out in a minute, but this is something we have been a part of. So S3A and RFI, that's what we think, and Thrimos. I see we conned the name up from a three-dimensional. Actually, it's actually more four. It's a four-dimensional subject because time's involved. But ignoring any of those thoughts, the point is we needed a way of gathering data, and we needed to perform measurement campaigns that we could seek the evidence we needed, or look at specific ideas of what might happen up there. So this is where we're going now. Here's interesting. My side of the thing, with a company called NetView here in the UK, we've automated this on the ground side. And we've worked with colleagues in Vienna, Space Analyse, and that is under an ESA project. So we have been a small part of this, but the bit that actually takes the clever part of setting up the experiment, shall we call it, and actually taking a measurement. And you've got to remember, where do you look? What are you going to look for? But look at that. At the moment, we've been over 35,000 contacts, and we've got over that many results. Formal results to ESA are certainly in the 20,000 plus area of contacts recorded. And here we go. Just in the month of November, in fact, less than 1 month, we actually found 5 RFI incidents of two Leo constellations interfering with each other. Actual proof, not we've all predicted it, but we've got it. And that led to an availability of 98.62%. And for instance, in 24 hours, we're looking at 200 to 300 contacts every 24 hours. And at the moment, we have one monitoring terminal. You're going to laugh when you see this. Well, not laugh, but you'll see. You wonder what we could do if we could do more. But guess what? The customers want 99.5. So there's 2 Leo constellations up there that are now not going to deliver that availability. We have proof, and we're seeing it on a regular basis from one monitoring station, which ends up as about a 3 millionth of the area covered by, let's say, Starlink at 550 kilometers, and a bit more if you go up to OneWeb at 1,000 kilometers or so. So the point is, we're looking in one tiny spot, and yet the availability is dropping even in that one spot. Imagine that on a global basis. I wonder what it would look like. I don't know, because I don't have that data, but I do have the data now and thousands of records to start to say we have a problem and you need to solve it. And if we have the data, if you think about it, we can move that on into a machine learning process, and we could probably put software-defined satellites that knew what they were doing and actually know when they're going to be in line with someone else's satellite and work it all out, and life could actually completely go away. In other words, predict your way out. So here's a reminder from September. I did this. Catherine kindly let me. I'm not sure whether I was the first one or not, but whatever. September 21. I got bored during COVID. I put an old Sky dish to test, started looking at zenith, 90 degrees, straight above my office. Guess what I found? 2 Starlinks crossing at the same point and just looking at their telemetry signals overlapping each other. So, okay. That needn't be interference in that sense. That can be managed, and that's in the same constellation. But it made me think, if that's happening already, remember that was 2020 when I did that recording. I mean, Starlink was probably 2,000 satellites or so at that point, something like that. Now, we're talking nearly 7. So the predictive is interesting. So there's a reminder of where the thinking was coming from on a practical basis. Oh, that was a video of it. I won't bother with that. It's boring. I was just in case. But the original thinking was to look at geo and check in the latitudes and the equatorial region of geo and see if anybody crossed that. And of course, as we've been discussing, look at Leo, RFI within its own constellation and between constellations. So that's where all this came from, being a little bit bored over COVID and putting a dish. So now it's automated. Thrymos exists. So here we are. We're basically all we're using is a small terminal, but the system is now in place. It's on AWS, cloud-based, and the whole thing can be measured from multiple monitoring points. It's all ready to go and it works, and we have the results to prove it. By the way, for everyone, this presentation will be made available. So if you don't get a chance to read, don't panic. It's going to be available. That's the setup. This is what it looks like here at the shed. We've got two antennas here. We've got one at KU looking at zenith, and we've got one at 70 degrees at KA band. We're looking wideband KU, all of it, 10.7 to 12.75 on the commercial receive side. And we're looking at KA 19.2 to 20.2 to cover things like iridium and some other pieces that use that particular part of the spectrum. So that's the setup. We're using a digital signal processor, very fast, of course. And we're doing that. It can, for instance, the processor can cover that 2.05 gigs of bandwidth it does roughly, I think it's about 50, can get 50 sweeps a second. So it's pretty fast and very accurate. You can see on the display a typical result coming through. So the process, cloud-based, that's where we build a contact plan, put it in the cloud, then our monitor system picks it up and actions it, and then the results are sent back to the cloud for the analysts to deal with. So the cloud is the way we control this. A contact plan builder simply builds a plan based on what something's going to do. And if I open this file here, there's a typical one. This was a 17-hour test, and it's all the sort of things, where the monitoring station is, what we're going to do, whether we're going to use TLE or the new orbital data message, OMM, the orbital mean messaging, which is just a posh version of TLE at the moment, but we can do orbital ephemeris data as well. But certainly you put it in a JSON file, and this one has endless satellites that are coming up, and then our monitoring system will simply pick each one. Remember, from where we are, using 0.75 meter antennas, that gives us no more than about 2.7 seconds of watching a Starlink satellite cross the 3dB beam width of that antenna. It's not long. So we have to be accurate, fast, and build the results ready for the next one. So as I said earlier, you saw we're getting some 300 contacts a day on average, just on this one antenna system. So we carry on. We look at the results just like before. And that's what Starlink looks like. We can look at Starlink on OneWeb. There's a website. Again, there's a link in there for that. I shan't worry about that now. Then we get the results in waterfall format or whatever. That's by the by. What you do with the data is something else. That's the exciting bit. That's beyond my capability here, but we're good at automating things. And so now we can say what we want to look at, automate it, all done, nobody touch it. It's been 24/7 since the day we installed it. It's working. The official system's down in Blandford Forum, just to the south of me here. And that system has been 24/7 collecting data, hence the number of contacts. So now we have a tool that starts to collect the data that we could now, if you completely throw that into the mix, we could start to manage our spectrum use. And also we could find out what spectrum aren't we using. I wonder how much spectrum up there that we all think is, oh, it's being used and nobody's using it. You'd be surprised looking at just the LEOs, how much is not used. You could argue, why not? Why not use it instead of having interference? Interesting thought. I'm not sure what the answer is. These are just some, don't worry about this. This is the thing I wanted to get to. thoughts, and these are my thoughts. They're not SIGs. Everybody probably will shoot me, and I've asked Catherine to. She can audit this list later and or throw it away or whatever. But here's what I think. How about a world's first? UK introduces National Spectrum Monitoring Scheme. Can we do something here for once and be first? It's simple. We just need small dishes. Keep watching. Okay, UK Space Agency, led, funded. Why not? They're at the top of the tree. This isn't going to be necessarily cheap, but it's not expensive, not in comparison to most of space funded things these days. We're talking, I worked out roughly that to have 1,000 monitoring stations in this country, fully automated and being able to collect, you're looking at probably a couple of £1 million, which sounds a lot, but in the scheme of investment in space, it's a doable. But let's keep going. Now I'm going to bring Catherine into this because I'm saying my group and your group, we could lead and promote. We can do this. We could be the people that help. Instead of UKSA having to do it all, we could almost be the project managers or something, or the leaders, or I don't know. I'm sure Catherine's got words to join the dots, shall we call it? I put at the end a little smiley there to cheer us up. But how about using our certainly our secondary or high schools, private schools, universities to be the monitoring sites? You'll see why in a minute. I think Catherine's got the answer. Make the result data available to our universities and analytic companies within the UK. Let people loose with the data to start finding out what's going on. Remember, from one site, we've proved something. Imagine what 1,000 sites doing something could start to prove, and you could consolidate and say, you know what, we're seeing real proof, not arbitrary, maybe suspect proof. But in the end, here's what I think the connection is in the end, which helps us join some more dots that we don't normally think about. Why not make it STEM inclusive? If we put the monitoring sites on the schools, you've just joined exactly. My school in Shaftesbury would love to do this. In fact, we're thinking of actually building and putting one there anyway, so that they become included in what I call the Dorset project at the moment. So there we are, everybody. That's my thinking, and that's what I'd like to do. I'd like to see something happen now. Yes, I know there's a commercial edge to this, but not that. We need, if we're going to solve and use spectrum properly, we need to understand, are we using it all? Do we use it properly? And how the heck are we going to manage this as it gets more complicated? No, not as it gets more complicated. In the current state of complication, it's here. It's no good us talking like it's a futuristic problem. It's always been here, and it's going to get worse. It's not going to get better if we don't do something. Thank you.
Thank you, Martin. That's really, really interesting ideas. And absolutely, we should have a conversation about how GNOSIS and SIG could at least explore this. And yes, you know that you're preaching to the converted about making data freely available to researchers and also using every opportunity for STEM engagement and inclusion. So. I'll park that for the moment, though, and open up for any questions from participants. Mark, do you want to speak, or shall I just read your question out? Give you a second if you want to unmute.
If you meant me, I'm just asking how we could improve that the states are giving their information to the UNOSA register, especially if we have some cases of space debris, so that they can manage the jurisdiction of control of certain objects. And on the other hand, we have the ITU with all the frequencies management, and we don't even know which one is used and which one is not used, as the speaker just said. There are so many frequencies unused that we have to make the connection between all the states and all the players in this field and to exchange the knowledge and to create more cooperation in space. That's my
Martin,
question. Thanks.
do you think we can make the ITU more efficient and effective? Because I think this is great stuff, and yes, I think the UK should, monitor and publish data and make it freely available, etc. Something to discuss with the UK government. But what I'm curious about is. I know that the UN processes are slow, but actually that is the best way to get global coordination and cooperation. So how can, is it lacking evidence? Is it just, bureaucratic processes? How can the ITU speed up its effectiveness in this area?
Yeah, I mean, my first thought, Catherine, is I think if they had the data in the first place, they could understand the spectrum problem better. They'd have something to put in front of that global audience to start to control the how they utilize frequencies, and maybe it would change the way they shape, divvy up the spectrum between players, where it's
Yeah.
you see where it was really needed and where we got space to put it, rather than we say you have this lump and we have that lump, and then everybody wants to fight over the same thing, and it's just a mess. I believe I think that I would hope that by getting data,
Yeah.
getting something tangible into the system is the only way the ITU is even going to be able to move forward.
I really like the idea of space situational and spectrum awareness. I think that's, I think that's a great idea. My thoughts that were triggered were that the UK just launched a National Space Operations Centre, which is all about sort of being able to report on the state of congestion in the space environment and including space weather. And I think this would be an interesting thing for those national space operations centers to be able to track and publish. I'm not aware of whether this sort of thing is tracked by others. I don't believe it's currently published by the UK Centre, but it's a question I will ask them the next time I see them. I see that, Michael Peel, you've mentioned that you actually are doing some similar things. I'd be curious if you had a minute to come on and just explain to people what you've been up to.
Yeah, I can do if you can hear me okay.
Yes, we can hear you.
Great. So I'm a radio astronomer, so I'm kind of worried about all the signals coming from all the satellites all the time, which are always interfering from our point of view. So just trying to understand what they're doing is really useful. And it's really difficult to find that out from FCC regulations, from ITU and everything. You don't know which bands they're actually using compared to, or even just finding what they're allowed to use is difficult. So I've been looking with some undergrad students here about building just small antennas. So we can either use satellite dishes or just a curved bit of metal to have a kind of broader beam in one direction. And then you can just use the LNBs to record the signal, put them into hack RFs, which is quite a nice, cheap way of doing it. So this was first on actually in UK by Bob Watson, I believe, a few years back. And that's a really nice thing to quickly get detections. The problem is you quickly get a lot of data and trying to figure out, okay, which satellites are we seeing and what's going on with each one is a difficult part. So I really like your idea of having high schools and things engaged with that. And I think you can do it for quite a cost-effective way. What I wonder is with the tool side of things, how you actually analyze the data, how you make sense of what's coming in is a complicated bit.
Well, we've automated that entirely. We actually set up the contacts so we actually know what we're going to actually look at based on where the dish is pointed. In other words, we know what's going to pass and exactly when. In other words, that's the toolbox. The smart bit would be, well, it doesn't matter. Any frequency, that's just the physical. The dish part, the antenna and what we put there is, it, like you say, I used a Sky dish to start with. It really doesn't have to be much. But we need a certain amount of quality there. Not terrible. That's the cheap part. The biggest problem is the digital processing of the spectrum fast enough, and the cloud then acts as your you can disperse that data to everyone at that point.
Hmm.
That's really easy. So the control of this is simple. Whether it's one terminal or a thousand terminals wouldn't make any difference to us now. Those contact plans can be generated. In fact, universities and others, with perhaps rights, would be able to create their own contact experiments. In other words, things we're thinking commercial here, but for you in astronomy and others, you might want to say, but I want to look for this. I'm trying to look for something specific. So the clever part is that you're building a contact. The contact plan, by the way, is a generic way that a lot of these, and I can't speak for all of them, but it's the sort of fundamental way they control a Leo constellation. In other words, the systems know what's happening, which ground antenna's got to look at what and when. And you build all this. It's just astrophysics and a bit of maths, you know. Ha ha ha.
Well, it
I'm
sounds
getting
like it sounds
yeah,
like it might be worth a follow-up conversation,
yes.
Michael, with Martin, just to
Thank you, Michael,
explore
by
that
the
a
way.
bit
But I
further. I
Yeah,
am conscious
definitely.
of the time because we always try and squeeze these into a lunch break. But I see that Ian has his hand up, and so I'm just going to go to him before we unfortunately have to wrap things up. Ian, oh, you're on
Hello,
mute. Now
hello,
you're off
hello. Yeah,
mute.
okay.
Hello.
It works. I'm just trying to work out which camera I was on, actually. Um, yes, so really, it's a bit about my area. I work in very low Earth orbit communications constellations, and I'm looking at direct to handset or direct to device, effectively extending terrestrial mobile services into space. And it looks like that's probably going to be the driver of the next big expansion of satellite constellations, delivering that service. And it seems there's kind of two ways it's going. There's a bit of a traditional ITU standardization way where they're going to identify specific bands for this service allocated. And I think, like Martin said, there's the 4 8 year cycle to deliver that. But in the style of most of these American entrepreneurs, there's a bit of a move fast and break things happening as well,
Hmm.
where they're kind of ignoring all that and going through just sharing terrestrial mobile providers for allocated frequency spectrums for non-terrestrial uses. And there's kind of two ways this is happening: slightly higher orbits, but huge antennas and very high powered, because ultimately you've got a very weak antenna at this end, if it's on my mobile phone. Or what potentially might be more of a concern is the next generation of Starlink is 20,000 satellites, 200 kilometers lower, with a lot of power. And I'm sure that concerns the radio astronomers as well, having even lower satellites emitting closer to the receivers. But really, I just wondered what your thoughts were on where that side's going to go, because that's a significant list. I mean, the first 7,500 have just been approved in very low Earth orbit for direct to handset, and that's going to be a lot of use of what traditionally would be terrestrial spectrum. So I just wonder what you see the challenges are going to be there.
I think it's exactly the same challenge we have now, except it'll be magnified. I think the problem of crossing over, we already see the ground interference with 5G and ground stations that satellite operations around the planet have got. It's a problem. Okay, we can get over it a bit, but it's caused a big headache. The sharing of frequency. You cannot really easily just share frequency. That is not a simple equation. Dear old physics comes into it once. And the other problem, of course, is you're actually, here's something else we've not even touched on yet. But a few of us in SIG have said for years that the noise power coming back to Earth, just the noise power of all the transmissions, especially as you say, another layer of Starlink going in lower down, more power, more noise. That noise is a problem. And noise, sadly, is all over the place. And you could start seeing some of these small dishes are going to be affected by the sheer noise power coming from space from us. No, I'm not looking any further than geo here. That's my mind, my brain cells only go as far as geo. But anybody else trying to work through that, and then we get to the situational bit. Well, I just don't know where we stop there. I honestly, and thank you. But it is the same problem. But if we can get data and keep collecting data, if nothing else, we'll see how things pan out and we'll have the proof of what the real problems are, not just might be. At the moment, we're just surmising and guessing. This is like I say, we have results here that are on certain boards of certain companies to be looked at as real interference problems. That availability has dropped, and that is a problem. So we shall see.
No, I think I think that is going to exacerbate things. We are looking at kicking off a piece of work in GNOSIS, just trying to identify areas where there's insufficient, we feel, monitoring of, indicators of the health of the space environment. And this is one area that I think we should be considering looking at. Federico has begged to have the floor for 1 minute. I do appreciate that people may need to leave, but I'm going to go ahead and indulge you, Federico, your short question.
Thank you. Thank you, Catherine. Very short. Martin, is the data that you're collecting available somewhere to look into that if someone is interested?
It is. I have to check because at the moment we're under the sort of slightly my colleagues in Vienna and the ESA lock and key at the moment. But if I use Catherine as my conduit to sort that out for you, leave it with me and I'll ask the question if we can get you some sample files of that. The problem is at the moment it's caught some companies by surprise, and I'm not sure whether we can let you. What we could do is let you see a typical result file of a satellite
Yeah.
passing, so that you just, oh look, that's what they look like. Whether I can send you the problem ones is another
Yeah.
matter, because that sort of opens a door that's the commercial satellite world. It gets in a hell of a knot. The fact that everybody else can't operate properly is neither here nor there. I'm afraid the sales teams win every time, but this guy.
Always.
Well,
Good
they
answer.
have
Thank you.
they have a reputation to protect, obviously, and it is a bad news story if you have evidence of this being a growing problem, And so,
And can I just thank all the guys who've spoken today?
yeah,
It's obviously, it's not just us, but if we're collecting data for the situational awareness of the physical side of space, we need to collect the data of the spectrum use in space, all of it. Now, we can't do that from one antenna and one DSP. It's got to be lots of, and maybe they'll all be at different frequency bands. It's not 1,000 all looking at KU band. We could have quite a mix going on. S band, perhaps, look at 5G in particular. I'm looking at Zenith continually, but we could pick different angles. You know what I mean? The experiments, if we had 1,000, let's say, my dream, over the UK, they could be doing batches of experiments at different angles, and we don't know. You think about it, we're looking at this tiny little spot. You can imagine what the spot is. I think it's tiny. It's only 25 by 36 kilometers at the Starlink average 500 odd kilometer orbit level. When that area of the sphere is huge at that point. So we're only looking at this, and yet the availability in that spot has dropped.
yeah.
That's all I can say is we got the numbers that tell us a story.
Yeah, very interesting finding. And, obviously what you want to do is ensure that those are replicated and it's not
Yes.
just, an anomaly, but I think we all wouldn't be so interested in the topic if we thought it was a rare and unusual occurrence.
Yeah,
So,
exactly. But imagine all these great people out there that, we're looking at it a certain way, but you throw it into younger people, older
yeah,
people, anywhere, throw it, that data out there. Someone's going to say, but did you see this?
yeah.
We're not, it's going to take more than one or two clever bunnies here. But if the data's not there, how do we get anybody to do anything? It's like Federico, you exactly the right thing. You want data to look at now. You're getting excited because you can start to see something and you would like to analyze it yourself. I get it. And all being well, I get you some examples, I think. And if that's at least will satisfy you a little bit for the minute, we'll okay, thank you, Federico. Anyway,
Okay.
Catherine, over to you.
Well, I'm going to try and be disciplined and wrap this up. But thanks very much, Martin, for that very interesting introduction to the conversation. It's clear to me that we need to probably make sure that we have a bigger conversation about this at our next conference this year, and also that we should definitely follow up. And I would encourage anybody who has attended or who watches this later to follow up with SIG to have discussions about their interest in this. It's you've put your contact details on there. It only is for me to finish by thanking everybody for participating, to flag that our next GNOSIS Connect, I won't take the time to put that poster up, is already up and available for registration, and will be on February 5th, where we will be looking at satellite operators' requirements for accuracy in collision avoidance. And so that's a kind of related 3SA, I'm going to get that acronym right, topic. And there are further to come in the calendar beyond that. I'd also just wanted to thank our sponsors, DSTL, CGI, and Astra Agency, for their support that lets us hold these events, and wish everybody a very happy 2025. I hope to see you soon at one of our next conversations. Have a great day.
Thank you, Catherine. Bye. Bye.